study session for IP addressing, and boy, did I not realize like how hard it is to talk sometimes. Like it wears me out. Like I don't know how teachers do it sometimes. But so what we're going to talk about in this study session, and before we get started, I wanted to say that I apologize for the previous video. There's some parts that it skips for no reason at all. Could be my internet. I'd say it's probably my internet more than likely, or the software I'm using. But other than that, let's get into this. And today we are going to be talking about IP addressing. What IP stands for is Internet Protocol. So what is an Internet Protocol? An Internet Protocol is an assigned numerical label that is used to identify Internet communicating devices on a computer network. In other words, it uniquely identifies computers on a network. So I guess what it's saying is it works on the layer 2 of the OSI model. So between two devices that are internal to own network or LAN, and it also works on layer 3 between two different networks or even two different subnets. Next is, now we're going to talk about IPv4 addressing, because there's two different types of addresses. There's IPv4 and IPv6 currently. So IPv4 stands for Internet Protocol version 4. It is written in dotted decimal notation, basically meaning that it's each number is 8 bits, is what that means. So each number between the dots is 8 bits. So each IPv4 address is divided into 4 separate numbers and divided by dots. So for example, 10 dot, let me close this real quick. So for example, 10.1.2.3 or 172.21.243.67. Each IPv4 address is divided into 4 separate numbers and divided by dots, which is what we just now talked about. Each of these divisions are called octets, so each number is an octet. So why do we call it an octet? That's because each number is represented by 8 bits. So you just need to know how to convert decimal to binary and binary to decimal, which is a good practice to do when you're studying for the Network Plus. So the IPv4 is 32 bits in length, because 4 times 8 is 32. Now, an IPv4 address is divided into a network portion and a unique host portion. So a network portion and a host portion. The host portion will always be a unique number assigned to that specific computer, and the network portion will always be the same depending on what network the computers are on. So the network portion will always be binary, meaning it will always have at least 1, and its binary number should be at least 1. And the host portion will always be 0. So for example, let's say we have an address as 192.168.1.4. Well, the network portion will always be represented by 8 ones, right? So 192.168.1 is the network portion, and it's represented by 8 ones in each notation. So 192 is represented by 8 ones. 168 is represented by 8 ones. Number 1 is represented by 8 ones. And now let's talk about the host bits. The host bits is 0, because it's going to be unique. It's not going to be the same, and that's why it's unique. So, and another concept to understand is the subnet mask. Now, subnet masks can be different sometimes, but when you're using a classful subnet mask, it's always going to be 255.255.255. So the network portion of a subnet mask, or the network portion of an IP address, is usually going to be 255.255.255. So 192.168.1 is 255.255.255, and then the unique host is represented as 0. Now let's talk about the different classes of IP address. So another thing to be, there is public classes and there is also private classes of IPs. So private classes can be used by anyone. A private class can be used by anyone, but public classes are reserved for ICANN. They basically manage public classes because they're routable IP addresses. You can actually have people connect to your computer through the internet. Now, there is a thing called NAT as well, which allows your private IP address to become a public IP address, but we'll get into that later. So, there's different types of classes. There's public classes and there's private classes. And this is a representation of, I want to say, all the classes, private and public. So let's just go ahead and talk about that. So there's an A, B, C, and D class. The A class is 1 through 126 for the first value, and that's with only one network, or with only one default mask, and that's 255, and then the rest is unique. Then there's class B, which is 128 through 191 for the first octet. After that, you can do whatever with the second octet, but it still has to be the same for every computer on that network, because it's a network ID. Same goes for class C. A class C is 255, 255, 255. The first octet has to be 192 through 223. But the other two, it doesn't really matter. And those are known as classful default masks. But these are like just all of them combined, I want to say. It could be just public, but there's also private classes as well, which we'll talk about. Now let's talk about routable IPs. So a routable IP is publicly routable IP addresses are globally managed by ICANN. So this is what we were talking about earlier, how public IPs are managed by ICANN. ICANN stands for Internet Corporation for Assigned Names and Numbers. And basically, they're the people who manage it. So if you wanted to buy a routable IP, you would actually, I think you can contact your internet company to do that as well, though. And then they probably get it from ICANN. I don't know. I would say that's how that works, but you'd have to do further research into that. Let me see, it might say it. Public IPs must be purchased before used through your internet service provider's ISP. So basically, you buy it and then you use it through ISP. Now we're going to talk about private IPs, which is what I was talking about earlier. So I want to say that those are routable IPs, that these are private. So private IPs can be used by anyone, meaning you don't have to buy them. You can literally just use them. They are not routable outside your local area network, though. So that's kind of the drawback through it. So there is something which we talked about earlier called NAT, which stands for Network Address Translation, which allows for routing of private IPs through a public IP. But you still have to have a public IP. So but anyways, let's kind of talk about some of the private IPs. You can have a class A, B, and C for a private IP. For class A, the first number will always be 10. So, for example, it could be 10.0.0.0, or it can be 10.1.1.1, and so forth, up to 255. But it only has one subnet. It only has one octet for a subnet mask, that being 10. Now, for class B, for private IP addresses, you can have 172.16.255.255 from 0 to 255. So, meaning class B has two subnet masks which you have to use. So, if you're on a network, for example, 172.16 through 31, it has to be 172.16 through 172.31. Has to be those numbers, no exceptions. The other two, can be whatever. But you have to use those two. Class C, 192.168.0.0 through 192.168 192.255.255. Class C has to be 192.168. No exceptions. There is no, it's not like Class B. It has to be 192.168, but the last two sections you can name whatever. So 192.168.1 would be the network ID, and 192.168.1 would be an example of the network ID for Class C, and 192.168.1.16, the 16 in that address would be the unique host ID. There are two specialized ID known as loopback and IPEPA. Loopback is used to actually test your Ethernet port, and IPEPA is an IP address that your computer gives you automatically if it cannot get if you do not have a static address for it, or if it cannot reach a DHCP server. So loopback refers to the device itself used for testing, most commonly used as 172.0.0.1. And then IPEPA, automatic private IP addressing, is dynamically assigned by the OS when DHCP server is down and address not assigned manually, like I said. Range of 169.254.whatever.whatever. But it will always have 169.254. That's kind of your indication of the IPEPA. Look for that 169.254, and for a loopback, it can be 127.0.0 through .1 through whatever, basically. So do be aware of that. So for a loopback address, for example, it doesn't have to be 127.0.0.1. It can be 127.1.10.1 if it wanted to be. Just be aware of that, but do know that it starts with 127, though. So now we're talking about how to identify a network and hosts in IPv4. So how do you identify that? It really comes down to how do you find the... It comes down to how you find the subnet mask, basically. So for example, for Class A network address example, the subnet mask is just 114, for example. So let's say it's 114.56.20.33. The 114 is the network portion because it has a subnet mask. It's 255, right? And the 255 is represented by 8 ones, right? Well, there is a way to find out. I don't know the exact formula for it, but there is a way to find out what that is, and it doesn't really explain it in the notes here. But 114.56.20.33, the 56.20.33 is the host portion. So that computer is represented by 3 different numbers. They're not necessarily saying how to find the 255. They're just saying that, just know that if an IP address has a subnet, has 2 subnet masks, for example, 255.255, that means that those 2 numbers represent the subnet mask, which is the network portion. And that's what they're saying there. They're not really saying how to find the subnet mask. They're just saying that if it has a subnet mask, that's the network portion. There is things known as virtual IP addresses, an IP address that does not correlate to an actual physical. So what is a virtual IP address? A virtual IP address, represented as VIP or VIPA, is an IP address that is not correlated to an actual physical network interface. It responds to numerous IP addresses and has them resolved to your physical network interface to establish connectivity. Basically, a virtual IP address is basically an IP address that is represented by one physical thing, but there's a lot of them. So this will explain a lot. Something called a sub-interface. So it's a virtual interface that is created by dividing up one physical interface into multiple logical. So one interface is basically filtered into a bunch of interfaces. And that's what makes up the virtual IP addresses, because each interface represents an IP address, right? So that's kind of like how that works, the virtual interface and the sub interfaces. So then there's different IPv4 data flows. There's unicast, meaning a packet will travel to one destination each. Then there's multicast, which means that you have a packet, but it goes to both computers. You specifically assign them. And then there's broadcast, which means one packet that you are sending goes to all computers. So now there's assigning IP addresses. There's two ways to go about this. There's static and dynamic. Static means you type in all the information yourself. And then dynamic means that you have a DHCP server that does it automatically. So what is the components of an IP address? What do you have to type in order to successfully have an IP address? You have to type in the IP address itself. You have to have a subnet mask for that IP address. You have to have a default gateway, and you have to have server addresses as well. So a DNS address and a Windows Internet Name Service, which you may or may not have. That, and if you're using a DHCP, you still have to type in the information. If you're using your own DHCP, I'd say you probably have to type in your information for that as well. So DHCP, what do you, like I said earlier, what do you have to use for what do you have to have in order for DHCP to work? You have to type in the IP. You have to have a subnet mask, a default gateway, DNS, Win server, other variables needed for voice over internet. But if you're basically unless you have that information, it's not gonna really, unless you're like a network administrator, you're not gonna need that, because usually people are just gonna use obtain IP address automatically, which connects to a local DHCP server basically over the internet. So I'll make sure I started this. Okay. That's kind of how. Now, let's say you use obtain DHCP server, okay? Let's say you use obtain an IP address automatically in your TCP/IP settings, right? So you click on IPv4 in the properties, and then it takes you to the Internet Protocol properties, TCP/IP. And you say, I want to obtain my IPv4 address automatically. I want to obtain my IPv6 address automatically. Okay, you did that, and the internet's not working. Why can't I connect to the internet? Always go to ipconfig in your control panel, or not control panel, but command prompt. Because sometimes that DHCP server might not work, and it might need refreshed. And there's a command for it. I think it's called refresh and reset, I believe. Something like that. If you go on the internet and say how to refresh your DHCP server, easily find it on Google. But the way you know that your DHCP server is not working is you will usually get an IP address starting with 169.254 with whatever interface you're using. So be aware of that. Be aware of that. And that's an important troubleshooting scenario you want to be aware of. Now, there's also something called zero config. It's a newer technology based on IPEPA. So it might say zero config in the command prompt. So zero con, C-O-N-F, but it stands for zero configuration. So. Now we're going to kind of talk about the number system when it comes to IP addresses. So how do you go about converting a decimal to binary, basically? Because that's what they use when they assign IPv4. So decimal is base 10, right? It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Computers and networks do not understand decimal. They only understand ones and zeros, so humans had to figure out it's basically base 2 with computers, because it's 0, 1, 0, 1, 1, 1, 0, 1, 0, 1. because they can only use 0 and 1, right? And that's known as binary. So humans had to figure out how to convert decimal to binary, because we understand decimal, right? And it's harder to read binary for humans, so we had to find a way to convert binary to decimal so we could understand, so we could interface with computers easier. So converting binary to decimal. Let's talk about this. Converting binary to decimal. So we like to use a table, usually that's like to the power of 2. And each number is the factor of 2. So starting from right to left, we would usually go 128, because there's 255 is the limit, right, for computers. So we'll usually do 128 to the power of 7, and then, well, 128 is 2 to the power of 7, 64 is 2 to the power of 6, and so on. So if we add up the columns that contain a 1, right, so there's a way to do this. So there's a table that we use, which is 128, 64, 32, 16, 8, 4, 2, 1. And that's in each column, right? So we got columns. And then we can convert the ones and add those numbers, which will give us a number of 150, which essentially tells us that that's the number that those ones and zeros are representing. So, in order to essentially convert decimal to binary, which is a cool way, you just use subtraction. So if you're wanting to convert binary to decimal, you add, but if you want to convert decimal to binary, you subtract. So it's a really easy way of doing it. Just memorize that table in your head. And if you don't know what I'm talking about, just go online and look up table for helping you how to convert and to decimal to binary and binary to decimal, and you'll see what I'm talking about. Now let's talk about subnetting, which is very, very crucially, I can't explain how crucial this is for the test. Know how to subnet for the test, and know how to convert decimal to binary. Okay? So, subnetting. I will continue, just give me 1 second. One sec, guys. Okay, I'm back, and apparently my mom was checking to make sure I was okay. But anyways, let's get back to subnetting. And I gotta take a picture because my buddy sent me a snap. Alright, subnetting. Let me see how much more we got. We have 1, 2, 3, 4, 5, 6, 7, 8. We don't have that much more. We just need to talk about subnetting, basically, and then that's pretty much it. Subnetting and IPv6, and then after that, we're pretty much done. So, let's go ahead and get that out of the way. Subnetting. So, subnet masks are rarely the optimal choice for the subnet size. So, basically, they're saying the default subnet masks, the class full subnet masks are barely used. Subnets can be modified using subnet masks to create networks that are better scoped. Creating a subnet involves borrowing bits from the original host portion. So what is the purpose of subnets? More efficient use of IP addresses than the classful default. Enables separation of networks for security. And enables bandwidth control. They do make something called a CIDR. That is a representation of basically how many subnets you can have. It's a, they also make a CIDR chart. Make sure to look that up on Google, and it'll show you the different, how many different subnets you can separate, and it's an easier way to understand subnetting. Now there is a subnetting formula, okay? So the subnetting formula, as I'm going to say it, is number of created subnets equals 2 to the s power. So the number of created subnets is 2 to how many subnets there are. So where s is the number, oh, I'm sorry, I said it wrong. Ignore that. So the subnetting formula, the number of created subnets is 2 to the s, where s is the number of barred bits. Now, here's the second formula. The number of assignable IP addresses equals 2 to the h minus 2, where h is the number of host bits. Remember that, because I guarantee you're going to have to use it for the test. Okay, so classful subnets versus subnetted networks, meaning they're not classful. So there's classful subnets, which is like 192.168.0 WAC 24 is a classful one, whereas a classless subnet is 192.168.1.64 WAC 26. So basically WAC 26 would be an unclassful one, and WAC 24 would be a classful one. But there's a chart for it, so make sure to look up that chart. Just look up a subnet chart, and it'll tell you, look up a chart for classful and classless subnets. And use those formulas I talked about in order to do the calculation for knowing whether it's classful or classless as well. Now we're going to talk about IPv6. IPv6 is more efficient than IPv4, actually, and they created IPv6 because they were running out of IPv4 addresses, and that's why IPv6 was essentially created. So the benefits of IPv6 is there's no broadcast, there's no fragmentation, it can coexist with IPv4, and it has a more simplified header. The IPv6 address structure, each hexadecimal has 4 bits. It's a total of 128 bits, and there is no more than 32 hexadecimal digits. IPv6 types, IPv6 address types, you can have unicast, it can be unicast, multicast, anycast. Do you need DHCP for IPv6? IPv6 uses auto configuration to discover the current network and selects its own host ID based on the MAC using EUI64 process. If you want to still use DHCP, there is a DHCP version 6 protocol. So basically you don't need it, but you can use it, I guess, depending on the situation. Stateless address auto configuration, also known as SLAAC, discovers the current network that an interface is located on, and then selects its own host ID based on the MAC address using the EUI64 process. EUI stands for Extended Unique Identifier. There is a protocol called NDP, Neighbor Discovery Protocol, used to learn layer 2 addresses on a network. Router solicitation, hosts sent messages to locate routers on link. And then there's IPv6 data flows, which we kind of talked about earlier. With IPv4, there's unicast, multicast, anycast. Now let's go ahead and go back and summarize kind of what we talked about in this chapter. So what we talked about in this chapter mostly was we went in detail about IPv4. We went into some details about subnetting. And we went into some details about IPv6. And we talked about in IPv6 how it actually doesn't need DHCP because it does that process automatically. But you can use it. We talked about unicast, multicast, anycast with IPv6 and IPv4. And then we talked about subnetting, which we talked about the different formulas involved in it and what a classless and classful subnet is. So that's gonna go ahead and sum up this chapter, and I see you guys next time. You guys have a good day, and I'll see you guys in the next one.